Hi everybody, today's screencast is all about polynomial and rational inequalities. You're going to learn how to solve both a polynomial and a rational inequality. What I'd like to start off though with is an overview of what you should expect. So first of all, I want to show you this polynomial function f of x, and this is the graph of f of x. You're going to be asked specific questions like, for example, when is f of x greater than 0? So I'd like you to have a visual of what you're asked. So if we want to know when f of x is greater than 0, we're basically being asked, when is this graph above the x-axis? Well, there are two sections when that happens. It happens here and it happens here. You're going to be writing your answers in interval notations. So the interval are going to be these x values that are highlighted in red. So when we write that in interval notation, it looks like this. It's from -4 to -1 and 3 to infinity. One of the things you're going to have to do is know when to use a parenthesis and when to use a bracket in your intervals. We are using parentheses here because we were given an inequality that does not have an equal to part to it. So that means we're going to have parentheses everywhere. The only time you're going to have a bracket, or you could have a bracket, is if there was a line under here. Okay, that's not happening in this example. Okay, so let's look at another example. In this example, we're looking at a rational function. So this is the graph of f of x. Now notice this rational function has asymptotes. Now the question is, when is this function less than or equal to 0? Now, there's an equal to part, right? So we're being asked, when is it less than or equal to 0? Well, it's less than 0 on this interval, but never equal to 0. And it's less than 0 on this interval, but it looks like it's equal to 0 at about -1. And then it's not less than 0 at all for this other section. So if we're looking for the intervals highlighted in red, it's going to go from -infinity until we get to -3, but not include -3 because we're not at 0 there, right? And then it's going to go from -1 until we get to 2, but not include 2. I don't know if I said -2 before, but I meant 2. So it's not going to include 2, but it is going to include -1. So this is what it looks like. So notice I have a parenthesis on -3 and a bracket on -1, a parenthesis on 2. Okay, now that's what's happening visually. That's what's happening with the graph. Let's go through this algebraically. So we have a polynomial function defined this way, and we want to know, when is this polynomial function greater than or equal to 0? So that means we have to solve the equation x plus 3 times x plus 1 times x minus 4 is greater than or equal to 0. We're solving that inequality, I should have said. So a good best practice for solving these types of problems, both for polynomial and rational inequalities, is to draw a number line and then label the number line with your critical points. And your critical points occur at -3, because that's what makes this parenthesis 0, because we're looking for when this side is going to be equal to 0. So that happens at -3, it happens at -1, and it happens at 4. You'll see that these 3 critical points have separated my number line into 4 sections. Those 4 sections are our possible answers, and they are intervals. The first interval goes from -infinity to -3. The second interval goes from -3 to -1. And the third interval from -1 to 4. And the last interval from 4 to infinity. Those are these 4 sections that we see on the number line. Now, what we're going to do is we're going to check each of those sections. So, for example, I want to pick a number that's clearly in this section, not an endpoint, a number in the middle. So -4 is in this first section. I'm working left to right. Now, all I want to know is if my function is positive or negative. See, I want to know when it's greater than 0. So all I want to know are those sections where I'm going to get a positive answer. So if I get a positive answer for -4, that means every number in this section will be positive. If I get a negative number, every number in that section will be negative. So I'm plugging -4 into each one of these parentheses for x. When I plug it in here, I get a negative number. When I plug it in here, I get a negative number. When I plug it in here, I get a negative number. And when I multiply a negative times a negative times a negative, that ends up being negative. Notice I don't care what number I actually end up with when I plug in -4. All I care about is if it's positive and negative. And I've determined that I will end up with a negative number when I plug in -4. So does a negative number work? If the left side of this inequality is negative, is it greater than 0? No. So there's no number in that section that works. That interval is not one of my answers. So now I'll plug in a number in this interval. So between -3 and -1, -2 looks like a nice, easy number to plug in. And I end up with a positive, negative, and negative. And a positive times those two negatives is going to end up being positive. Is a positive number greater than or equal to 0? Absolutely. So that interval is part of my answer. So now I'm going to check a number between -1 and 4. Anytime I can use 0, I'm going to use 0 because that's an easy number to plug in. And if you plug in 0, you get positive, positive, and a negative. And a positive times a negative is negative, and a negative number does not work. And then for this last section, a number in this interval from 4 to infinity, a nice easy number to plug in would be 5. When I plug in 5, this is positive, this is positive, this is positive. And if I multiply all positives together, I get a positive number, and so that interval works. Kind of cool, right? So which intervals ended up working? The interval from -3 to -1 and the interval from 4 to infinity. And that's my solution set. Okay, look at the graph of this. Use your calculator, type this in, and you'll verify that you're going to get the same answer. When is f of x greater than or equal to 0? When is it above or at the x-axis? And that's this interval and this interval. Okay, let's do an inequality with a rational function in our next example. So first we have the rational function f of x equals x minus 1 over x plus 2. We want to know when is this function greater than 0. To solve this, we're going to have to solve the inequality x minus 1 over x plus 2 is greater than 0. Okay, we've got to find those critical values. To find the critical values of a rational inequality, you want to think about x-intercepts and vertical asymptotes. So remember, the x-intercepts come from the numerator being equal to 0, and the asymptotes come from the denominator being equal to 0. So what makes the numerator and the denominator equal to 0? Those are the numbers we're going to graph on our number line. So the denominator is 0 at -2, and the numerator is 0 at 1. That's how we come up with those critical values. Now, how many intervals do we have? We have 3 sections to our graph. Those 3 sections are -infinity to -2, -2 to 1, and 1 to infinity. Parentheses everywhere. Why? Because there's no line under this inequality. Now, remember, just like the last time, we need to check these. So plug in a number between -infinity to -2, like -3. be careful here. Be careful picking that number. Remember, don't pick -1 because that wouldn't be in that interval, right? So -3 is a number that's in this interval. And when I plug in -3, I plug it in the top and the bottom. I get a negative on top and a negative number on the bottom. And a negative divided by a negative is positive. Do I want positive numbers? I do. So that is part of my answer. Okay, what's the number between -2 and 1? I like to use 0 when I can. So when I plug in 0, I get a negative on top, a positive on the bottom, and that ends up being negative. And negative numbers do not work. And in the last section, a nice number to use between 1 and infinity is 2. When I plug in 2, on the top I get a positive number, on the bottom I get a positive number, and a positive divided by a positive is positive, and a positive works. You should have noticed a little pattern here. When you're checking these intervals, as long as you list them in order from left to right, 99.5% of the time, when you do your check, they're going to alternate. Works, doesn't work, works, or doesn't work, works, doesn't work. Okay? So you're going to always alternate positive, negative, positive, negative, positive, negative. All right, so in this example, the two intervals that worked are -infinity to -2 and from 1 to infinity, and that's our solution set. Okay, look at it graphically. If we graph this polynomial function, f of x is equal to x minus 1 over x plus 2, you can see when is this above the x-axis from -infinity to -2, and if we're above the x-axis from +2 to infinity, +1, sorry, to infinity. +1, it's going through 1 on the x-axis. Sorry about that. Okay, let's look at our last example. Now, this is not a function, but an inequality, straight off the bat. So we want to know when is the rational expression x over x minus 5 less than or equal to 2. Well, we're going to have to set that inequality to have 0 on the right-hand side. So we're going to subtract 2 from both sides of the inequality. And then I have to find a common denominator. So the common denominator is x minus 5. So I have x over x minus 5 minus 2 times x minus 5 over x minus 5. One thing that students get wrong is they have trouble when they distribute this -2. So notice I have x minus 2x plus 10. Make sure you understand why that's a positive 10 up top. Okay, and the denominator is x minus 5. And when I simplify that, I end up with -x plus 10 over x minus 5. And that's less than or equal to 0. So what are my critical values? Well, my critical values are what makes the numerator 0 and what makes the denominator 0. So what makes the numerator 0? Well, what makes the numerator 0 would be 10, and what makes the denominator 0 would be 5. Now I'm marking those on my number line, but I want you to notice I put an open circle on 5 and a closed circle on 10. Now let me explain why I did that. This inequality does have an equal to part, but this is a rational inequality. And the denominator is not allowed to be equal to 5. So that's why I put an open circle there. But it is allowed to be equal to 10. Okay, now what are my intervals then? So the interval here, I have 3 intervals. So my intervals go from -infinity to 5, not including 5, from 5 to 10, not including 5, but including 10. That's why there's a bracket on 10. And from 10 to infinity. Please pay attention to the parentheses and brackets here. Make sure you understand why I'm using parentheses and brackets. Okay, and then we're going to check each of those intervals using numbers that are in the interval, not the actual endpoints. So for example, in the first one, I'm going to use 0 because every time I can use 0, I do. And I'm going to plug 0 down here into this simplified rational expression. So when I plug in 0, the top is positive and the bottom is negative. And a positive divided by a negative is negative. Does that work? That answer is yes. Now I'm going to plug in a number between 5 and 10, like 6. So when I plug in 6, I end up with a positive over a positive. And a positive over a positive is positive, and a positive number is not less than 0. So that does not work. And then I'm going to plug in a number between 10 and infinity, like 11. When I plug in 11, I get a negative number over a positive number, and that ends up being negative, and that does work. So the intervals that work are negative infinity to 5, not including 5, and the interval from 10 to infinity, including 10. And so the solution set is negative infinity to 5, union 10 to infinity. Notice the brackets and parentheses there. Just real quick, I want to show you in this next screen the graph. You could do it one of two ways. You could graph x over x minus 5 in your first y equals and x equals 2 in the next one, and look for the intervals when the blue graph is below the red graph. Okay, that happens here and that happens here. Or you can graph this one, negative x plus 10 over x minus 5 is less than or equal to 0. And you can determine when it's going to be below the x-axis. And remember, those answers are from negative infinity to 5 and from 10 to infinity. You can see that on both of these graphs. All right, I hope that was helpful. I know this was a long screencast, but you're doing well. Email me with any questions.